Hello mathematicians, we're going to take a quick look at shifting and reflecting known graphs or transforming them. And these points here are the ones that we really need to be sure about. So I'll jump to a GeoGebra, look at an example there, and then we might come back and have a look at a different example after that. So suppose we have some function of x. Now clearly this function of x is a parabola of some sort. So if this is what f of x looks like, if I do this one first of all, if I take the minus f of x, then every positive value is going to become a negative and vice versa. So what that does is it reflects in the x-axis. So minus the function of x reflects in the x-axis. If I take the function of minus x, so that means that I substitute minus x for x in whatever my function equation is, then the result is that I reflect in the y-axis, which we can see just there. If I take my original function, y equals f of x, and I add a constant, then depending on the constant, the curve is going to go up if it's a positive value, down if it's a negative value. And if I take my original function and I replace x with x minus k, then depending on my value of k, the curve is going to go left or right. So if k is a positive number, so I'm subtracting a positive number, the curve will go to the right. If k is a negative, so I'm subtracting a negative, which means adding, then my curve will go to the left. Finally, down the bottom here, if I have minus f of minus x, then I've got two transformations. F of minus x reflects it in the y-axis, and the minus reflects it in the x-axis. So I get this. So if you can imagine that if I first of all did this, and then I did that, then that would give me the reflection or the transformation as shown. Just try and squeeze around here somewhere some examples. So if we consider, for argument's sake, y equals x cubed, which we know looks like that, then if I look at y equals minus f of x, that would be minus x cubed, which is the reflection of this curve in the x-axis. So that's y equals minus of x cubed. Whereas if I take the function of minus x, so I take minus x all cubed, and look at that graph, and I'll just change the colours here, then it reflects the curve in the y-axis. But the original curve reflected in the y-axis looks the same as the one we just drew. And the reason is that if I take minus x and cube it, then that becomes minus of x cubed if I remove the brackets. If I take f of x plus k, then say I take y equals x cubed plus 1, it takes my original curve and slides it up the axis, so it intersects at 1. And lastly, if I take y equals the function of x minus k, so for example y equals x minus 1 all cubed, then that shifts my original curve in here to the right by one place. So it looks like this, and it's cutting through at 1. Now it's worth applying those shifts to all the curves that you know, so you can see how these transformations work. Okay, so a quick look at a couple of these equations, these transformations, because we did them in class. So if I have f of x plus 1, for example, we know that that takes this curve and it shifts it to the left by one place. So if I imagine doing that, I'm going to get something vaguely like that. This one down here, y minus 1 equals hx. Well, that's a little of a trick one. That means y equals hx plus 1. So I take this curve and I shift it up by 1. So this 1 will become a 2, and my curve is going to look something like that. Similarly, this one here will become y equals g of x plus 1, which means that I take this curve and shift it up by 1. I won't draw that because it's going to get lost if I try and draw this one. So this is that curve shifted to the right by 1. So it will look something like that. We also had a quick look at this to find the centre and radius of this circle. So start to set it up for completion of squares. So x squared minus 6x, y squared minus 4y. Take that 4 here over to the other side, so it's negative 4. Complete the square on this, so half of minus 6, which is minus 3, and square it. So that gives me the perfect square x minus 3 squared. On this one, minus 2 squared is 4, so that gives me y minus 2 all squared. And because I added 9 and 4 there, I have to add 9 and 4 over here, which gives me 9. So what I have is a circle, centre 3, 2, plus 3, 2, and radius 3, square root of 9.